Right, here is our third part of lesson 15, and this is all to do with scatter graphs. Right, scatter graphs is where we try to make a correlation between two separate events. Yeah, for example, because we're doing a GCSE, it may be, is there a correlation between maths and English percentage in their exam results? Yeah, if somebody is good at maths, with the scatter graph, can we prove or disprove whether they're also good at English? And this information, you can only assess the information on the data that you're given, so don't go too crazy. Yeah, so let's have a look at this. So we'll put a line down here, there, and we'll put another one over here or there, and we'll put some English percentage, and up here math percentage. So we're going to go from percentage, so we may as well just go 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. And the same along the bottom, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Right, that'll all be drawn for you, so don't worry. Now you're going to get a table of, I won't do the table, I'll just do the numbers of what someone scored in maths and what someone scored in English. And it'll be a random selection from everybody polled. Obviously, we know that the more people you survey or the more people you poll, the more accurate your results will be. Your conclusions will be more accurate. But in this case, that is a 7. But in this case, we don't want to do too many, otherwise will be too long, won't we? So it's just to get the idea of what we're doing. So these maths and English results are going to give us our coordinates of where we need to draw the things. So 20 and 30. So 20 on the maths, 30 on the English goes there. 40, 40, 40, 40, there. 40, 50, 40, 50 is there. And what we got now? 60, 75, 60, 75 halfway across that one. 70 and 20, 70 and 20, 70 and 20 there. And 80 and 80, 80 and 80. Okay, 80 and 80. Right, there you go. So there's all our little scattered coordinates, hence scatter graph. And first thing is, the question is, identify the outlier. Yeah, most of these are all together and they're trending upwards. They're all sort of together. This one over here, whoa, that's way different from the rest, so that's an anomaly. This is our outlier. And then you have to draw a line of best fit. Draw a line of best fit. Now that is a line that will go through all our coordinates, but more or less, yeah, just goes up through the middle of them all. So you've more or less got the same on the above the line and below the line. Ignore the outlier. Now be careful not to go beyond the edge of the known data. You can't just carry on, yeah, assume that's going to happen. It might not. The second question, based on your line of best fit that you've done, is what English percent would you expect if you get 50% in maths. Okay, right. So we need to draw from our 50% in maths, go along to our line of best fit, and this is where everybody will draw their line of best fit a little bit different. So don't worry, they will allow you, there'll be a tolerance built into the answer. Anything between this and that, they'll say. Oops. Yeah, do this with a pencil before you commit to down there. And I reckon that that is more or less, I don't know, about 57%. So if someone scored 50 in maths, you'd expect them to get 57 in English, according to the data that we've got. Of course, there's no way you can actually predict that. But I mean, if you did thousands of them, like the whole nation you did, then you might expect. So this suggests to us that the better you are at one subject, you're also better at the other one. Now there's a trick question that they ask, just to make sure you've done your line of best fit correctly. They would see what English, I'm going to do exactly the same. English percentage would you expect if you get 10% in maths? Okay, now trick question, because if you look along the 10% line from maths, along there, it doesn't meet our line of best fit because it's beyond the bottom of the graph. Yeah, so you can't just go, oh, it might be about there and it might be about there. It's not going to happen. Yeah, so this is just testing you to see whether you continue your line all the way to the bottom or not. And so your answer for this one is going to be can't predict as beyond the data range. And the same at the other end. If somebody had 90% in maths, it misses the top, so we had no idea what they would have. Yeah, can't predict as it's beyond the data range. Okay, so the other kind of things for the scatter graphs is identifying correlation. All right, this is simply just matching up graph A with description C, graph C with description D, that sort of thing. So identifying correlation. So here we are. So we've got 4 little graphs similar to the one in real times, because there's no numbers or anything. Yeah, so these are going uphill. Yeah, so these are going uphill because everything in maths in the graphs goes from left to right. Now uphill, and they're all pretty close together, aren't they? So when it goes uphill, it's positive. And when they're close together, it's a strong positive. So you can probably already guess what all the other ones are going to be, but we'll do them anyway. So we do another uphill, but this time the coordinates, the little stars, are a bit further apart, but you can still see it's going uphill. So this is going to be a weak positive, and then you've got your downhill ones, and it's like this. Yep, so this is going to be a strong negative. Now the reasons why these are positive and negative, you might have come across in another lesson already, is when we're calculating gradients of lines. If it goes uphill, it's a positive gradient. If it goes downhill, it's a negative gradient. So this is more or less the same, but it's just going to see what's going downhill, but they're a bit far apart. So this is going to be a weak negative. And of course this one down here, which I haven't drawn yet, this is just going to be nothing, none. No correlation whatsoever. Okay, so there's your scatter graphs, part 3 of lesson 15.